So this is given the force in the direction dot dr, or we have to find the total work done. And dr we note r as our position vector as x cap x I cap plus y j cap. So dr will be dx I cap plus dy j cap. So we have to find this f, or work done in f dot dr, and some of the things are missing. What am I missing? Yeah, so the curve given here, it is y is equals to x square, and the points given here are from 0 comma 0 to 1 comma 1. It's a very simple form of simple curve. That's y equals to x square is a parabola. It's something like this, and so we have to find this is about our x-axis, and this is our y-axis. So as the x increases, y goes like this. Y takes the function of x square. So we have to find it from 0 comma 0 to 1 comma 1. So if I can draw something like this, here it is our 0 comma 0. Here we have our 1 comma 0, and here we have our 0 comma 1. So this point will be 1 comma 1. So we have to find this line integral from this line to this line. That is the work done from suppose putting a ball of mass m from this position to this position. So o- as we know that this is a conservative force, so it is a path independent force. So we can take any one direction, suppose from here to here, or from here to here and here to here. The net work done will be same. Work done will be conserved. So in this case, we can proceed like this. Suppose let us name this path as C, this path as B, and this path as A. So we can proceed it in two ways, like consider path A plus path B, or just path C. So if we consider the above situation, suppose the case 1 situation where we have path A plus path B. In that situation, we have to go from 0 comma 0 to 1 comma 0, then 1 comma 0 to 1 comma 1. So from 0 comma 0, okay, let's first write, and at the top we can see our f is this. So f is, we have to find the line integral, right? So f dot dr, so this will include uh, x square I cap plus y cube j cap dot product of dx I cap plus dy j cap. So we have to run the integral from this integral will run from according to that path we are selecting. Suppose we select path A. So for path A, we have this integral will run from, and when we solve this, this will come as x square dx plus y cube dy, because I dot I cap is equals to 1, j dot j cap is equals to 1. Otherwise, it's any combination, it's 0. Okay, so we have x square dx plus y cube dy. Now we are considering just the path A. So in path A, you can see that the changes are in the x coordinate. That is, it changes from 0 to 1. So we will integrate it from 0 to 1. And the y coordinate stays fixed at y equals to 0 or dy equals to 0. So this particular thing goes entirely to 0. So we have entirely this one, and this results into x cubed by 3, varying from 0 to 1, which is, uh, we can guess it's 1 by 3. So similarly, path B, path B, path B is this, path B is this. So for path B, we can do one thing. We can again set the same integral, x square dx plus y cube dy, and in this case x is constant, that is x equals to 1 or dx equals to your 0. So this particular whole thing goes to 0, and this integral changes according to y, and y shifts from 0 to 1. Y shifts from 0 to 1. So we have 0 in here and 1 here, the limits. So finally we get y to the power 4 by 4, ranging from 0 to 1, or again we get 1 by 4. So when we add them, path A plus path B, our total work is 1 by 3 plus 1 by 4, which is equals to 7 by 12. This was the case 1 when we have chosen just the path A and path B. Now consider path C or path C. Path C is just a minute. Path C is this path. So let us draw this. Let me draw it perfectly. Not that perfect. Okay, let's remove these things. I don't know why these comments are coming. Okay. Okay. So this is our 0, 0. This is our 1, 0. This is 1, 1. This is 0, 1. So this is our path C. So when we see path C, we can find this is the equation of a line, and in this case, we have already been given a curve C, the curve as y equals to x square. This has already been given to us, so we can write it as y equals to x square, or dy is equals to 2x dx. Finally, let's put this entire thing in this particular equation, that is integral from x square dx plus y cube dy. So in y cube we will put x square, and dy we will put 2x dx. So we will get x square dx plus y cube in this, if we put x square, this will come to be x to the power 6, and dy if we put 2x, so this will change into 7, and we will have 2x dx. Now if we integrate this from 0 to 1, because our x changes from 0 to 1, so we will have, because x changes from 0 to 1, so we will have x to the power 3 by 3 plus 2x to the power 8 by 8, 4. Again the same thing, 0 to 1. This will turn out to be 1 by 3 plus 1 by 4, which is equals to 7 by 2. So one can pause here, or one can calculate this entire thing again from the beginning and see that in both the cases, if we follow path A plus path B, then we'll reach 1 comma 1, and if we just directly follow path C, we'll also reach 1 comma 1. So this is a way to calculate line integral, and I think this video has been helpful to you. So like, share, and subscribe. Thank you.